Okay, it was really cool to hear from some of you today, and as requested, here is the working out of the average value and accumulation problems. All right, so in number one, it says what is the average value of 3t cubed minus t squared over negative 1 to 2? So by formula, we take 1 over 2 minus negative 1 times the integral from negative 1 to 2 of 3t cubed minus t squared dt. So this is going to be a third times 3/4 t to the fourth minus a third t cubed from negative 1 to 2. We'll leave the third outside. So let's see, 2 to the fourth is going to be 16. So this is 3/4 times 16 minus a third times 8 minus, okay, so that's just going to be 3/4. And this is going to be plus 1/3. All right. So let's see. 4 goes into 16 4 times 3 is 12. Minus 8/3 minus 3/4. Distribute the negative is going to make that minus a third. Let's see. So this is a third. 12 minus, let's see, 8/3 minus 1/3 is 9/3, so that's minus 3. Minus 3/4. A third. 9 minus 3/4. Distribute the third through that, and we're going to get 3 minus 1/4, which is 2 3/4, which is 11 over 4. And I believe that's answer A. So there's number one. All right, so number two is the average value of the square root of x over the interval from 0 to 2. So that's 1 over 2 minus 0, integral from 0 to 2 of x to the 1/2 dx. So that's 1/2 times 2/3 x to the 3/2 from 0 to 2. So that's a half. Let's see, that's going to be 2/3 times the square root of 8, right, minus 0. So that's 1/3 times the square root of 8. The square root of 8 is 2 radical 2, so that's going to be 2 radical 2 over 3, which is letter C. So there's 2. All right, looking at problem 3, we have an average value from 0 to 2 of x squared times the square root of x cubed plus 1. So let's go stop. Sorry about that. So let's go 1 to 2 minus 0 times the integral from 0 to 2 of x squared times the square root of x cubed plus 1 dx. So this is u substitution. Make this x cubed plus 1. Du dx is 2x squared. So dx is du over 2x squared. So this is going to give me 1/2. Let's change the bounds of integration. This one's going to become 1. That one's going to become 9. That's x squared u to the 1/2 du over 2x squared. So that's going to give me, back here, 3x squared. All right, we fixed that. 3x squared, 3, right? Because the 3 comes down, we leave 2. Aha. So that's going to give me 1/6 from 1 to 9. The x squareds cancel. U to the 1/2 du. So that's 1/6 times 2/3 u to the 3/2 from 1 to 9. So this is going to give me 1/6 times 2/3. Let's see. Let's see, what do we got there? That's 9, 1 to 9, not 1 to 2. There we go. So square root of 9 is 3. 3 cubed is 27 minus just 2/3, right? Because 1 to the 3 halves is going to be 2/3. So 27 over 3, that's going to give me 1/6, 9/18 minus 2/3. Right, so let's take the 6th through that. That's going to give me 3 minus 2 over 18, which is 3 minus a 9th, which is 2 and 8/9. 18 and 2 and 6 is 26 over 9, and that's A. Alright, so that one is involving a little bit of U substitution. So there you have it. Sorry about the little bobbles along the way there, but I think we got it. So let's look at number 4. We want the average value of y equals 3x minus x squared in the first quadrant. Okay, so what I figured out here was to take 3x minus x squared and see where the zeros are. So that's going to be x times 3 minus x is 0, so x is either equal to 0 or x is 3. Alright, so if I think about this, this is a 0 at 0. It is a 0 at 3. It's a downward facing parabola. So the only part of the parabola that's in the first quadrant is this part from 0 to 3. So I want to take 1 over 3 minus 0, integral from 0 to 3 of 3x minus x squared dx, which is 1/3, and let's see, that's going to be 3 halves x squared minus 1/3 x cubed from 0 to 3, so that's 1/3. Let's see, 3 squared is 9, so that's going to give me 27 over 2 minus 27 over 3, and then the other part's 0 minus 0. So a little distributing here, I get 9 over 2 minus 9 over 3, which is 27 over 6 minus 18 over 6, which is 9 over 6, which is 3 halves. So that's C. There you go. Let's take a look at number 5 here. We have, what is the average value of 1 over x in the closed interval 1 to 3. So we're 1 over 3 minus 1. From 1 to 3, 1 over x dx. Fortunately, 0 is not on that interval, so we don't have to deal with anything weird there. So this is going to be 1/2. This gives me natural log of x from 1 to 3. So this is 1/2 natural log of 3 minus the natural log of 1. But the natural log of 1 is 0, so this is the natural log of 3 over 2, which is D. Whole problem. All right, so if you take a look at number 6 here, you got a little graph there. It says the flow of oil in barrels through a pipeline July 9th is given by the graph shown above. Of the following, which best approximates the total number of barrels that passed through the pipeline that day? So what we need here is an accumulation from 0 to 24 of that function, f of x dx, Well, that's just the area under the curve. And if you look at that, that's roughly 1, 2, 3, 4, 5 squares. And each of those squares is 6 wide and 100 tall, so they're each going to be 600, which gives me approximately 3,000. So we pick answer D. All right, so looking at problem number 7, they give me a rate of change, and they ask me to find the total change in altitude when the balloon is decreasing. So the first thing I need to do is figure out where is the balloon decreasing. So that's when t cubed minus 4t squared plus 6 is going to be less than or equal to 0. So this is a calculator active problem. So let's break out the calculator and find out when that's true. All right, so let me turn my calculator on, and I've already got it in there. X cubed plus 4x squared plus 6. So let's window this. It makes sense to go from 0 to 8 because that's the domain. And we're going to graph this. And if I look at the graph there, that makes sense because this is a third degree polynomial. So the end behavior should go up off to infinity over there. So I need to know where this thing is negative. So let me find those two zeros. Okay, so let's put in a 1. Let's put in a 3 and maybe a 1.5. Makes the first 0 at like 1.572. And then let's put in the second 0. So let's see, that's going to be somewhere between 3 and 5, maybe around 3.5. Looks like it's at 3.514. So let's go transfer those numbers over to the other sheet. So my descent will be the accumulation from 1.572 to 3.514 of this function, right? And this function is what we are calling R of t, dt, right? Because R of t is already the rate of change, so we don't have to take the derivative of this. It is the derivative, so the total change in altitude would be the integral of this, which gives me letter B, or sorry, not B, A. There we go. Don't want to confuse that. All right, so let's move on to the next problem. Okay, looking at number 8, we have a pizza that's starting at 350 degrees. It's taken out of the oven. It's cooling in a room that's 75 degrees. The 75 here is somewhat irrelevant. It starts cooling at time 0. The cooling curve is given there. So we want to know the temperature at time 5. So we know that the integral from 0 to 5 of negative 110 e to the negative 0.4 t is equal to the temperature at time 5 minus the temperature at time 0. But we know the temperature at time 0 is 350, so we should be able to rewrite this as 350 minus the integral from 0 to 5 of negative 110 e to the negative 0.4 t dt. But this is a calculator active problem, so you should take all of this, throw that into the calculator, and you're going to get approximately 112. So that should be letter A. Okay, so let's look at number 9. Number 9 says insects destroyed a crop at, there's the rate of change, in tons. We want to know how many tons were destroyed between time 7 and time 14. So this is simply the integral from 7 to 14 of that rate function. To minus e to the negative 3t dt. You throw that into the calculator and you get approximately 125. Whole problem. There you go. Number 10 is incredibly like number 9, the rate is given to us. We have an interval from 0 to 5. So really, it's exactly the same problem. You take the integral from 0 to 5 of 12 times the square root of t over t plus 1 dt. This is a calculator active problem, so you're going to get 47.193, which is letter D. All right, so there's the solutions as promised. Hope this is helpful. If not, send me emails, see me in the drop-in, whatever you need. All right, I hope you're well, and I hope to hear from you soon.